Hi, good morning everyone. Morning ladies and gentlemen. Thank you for coming to today's seminar titled Step into Perfection, Mastering Flat Flooring and Concrete Repair Solution. So the entire seminar for today will be split into two portions. The morning portion will be focusing on flat floor, and the afternoon session after lunch will be focusing on concrete repairs. In the morning, we would have the team from Concrete presenting to us. We will have Colin, Gary, and Jason with us. We will start off. At 9, and then we would end at a short break. But because of the time constraint, maybe we will shorten the break a bit. First of all, can you get everyone from the back to fill up the seats in front? Everyone from the back, can we get everyone fill up the seats in front? We will take photos in the middle of the seminar later, so we would like it to be filled in front. Those from the back, please. Can you get all the spaces filled in front? Those from the last row, everybody from the last row, can you all have to fill up in front, please? Okay, when we start off later on, this will be not as formal as a lecture or as a meeting. Okay, feel free to ask anything that you're unsure of in between. You all can raise your hand at any time, I believe. If anybody is unsure of anything, feel free to ask any time. You do not need to remember and wait till the question and answer session to ask our team here. It's a sharing session, so feel free to ask. They will provide you with a suitable solution. And our presenter for today, first of all, Colin will be the co-founder of Concrete. So we have the co-founder of Concrete joining us today to share his insight. We have Gary as well. Gary, with his vast experience, he will share everything there is to know, technical side. As for Jason is, I believe he flew all the way from Korea. So he has done about 1 million meters squares of flat floor in Korea. So in the presentation later, we will also share about case studies. We will not only share what is there to do, what is not to do, but also what are the specific failures and how is it to repair. So, like what I said earlier, if there's any questions in between, just raise your hand, ask away, so everybody will be able to learn and know from each other. And without further ado, let me welcome. Yes. Oh, yeah, we will do that. So, without further ado, let's welcome the team from Concrete.
Good morning. Test the system out. Can everyone hear me all right?
Yeah.
Doesn't sound quite so accurate, so I can hear myself. Ladies and gentlemen, colleagues, good morning. Welcome to this presentation. I'd like to give a big thank you to Mr. Young and Lkl for inviting us to do this. It's an honour. Sorry, not used to speaking into the speaker anymore. Okay, so today we will be going to give a talk on building a concrete industrial floor, which is fit for purpose. It's a very important phrase, it's fit for purpose, which we'll come on to. Now, this subject of building flat floors is a big subject, and I cannot possibly cover a lot of it in one session. But I'm covering something that I think is a starting point from what I understand in the marketplace. So we're going to just flick in here, so a little bit of things out of the way first of all. Face Consultants, this is a dual presentation anyway. Face Consultants is part of the Concrete group. And I'm doing this presentation under Face because it's a bit of a consultancy exercise. So face consultants are experts in the design, surveying, and testing and commissioning of concrete flat floors. We're also independent. Face is independent. It's independent from Cobri when it comes to the consultancy work that it does. Cobri, on the other hand, is a solution provider for design and construct of high performance, high tolerance concrete industrial floors. And these solutions are fit for purpose. What else we'll talk about it. I think on here you can see we've got red dots and blue dots. And the red dots are Cobri and the blue dots are face. So you can see that we're scattered around the world, making the world a flatter place. So on to the next one. Today we're trying to make it more localized. So in terms of our setup in this area, our head office for Asia is actually in Singapore. We have a satellite regional office in Seoul, Korea, and from Singapore, for the ASEAN region, we have an office here in Kuala Lumpur, and we have face and Cobri there, and then we also have an agent in Senai area. Alright, so Cobri and face are substantial contributors to UK Concrete Society Technical Report number 34. This is one of the most comprehensive and widely used guides for the design and construction of concrete industrial floors. FACE are working closely in collaboration with all the major developers in the next generation materials handling system, which is robotics. I was thinking about this last night. What does this mean? Malaysia is only at the beginning. In fact, Singapore is only at the beginning of an automation involving robotics. And Malaysia is a bit behind that as well. In Korea, we're actually making big roads in there now because there are big players, and Korea is a very advanced country on this front. Now, typical robotic systems would be in places like, what's the name of it? Where do we buy our stuff from?
Amazon.
Sorry?
Amazon.
Amazon, yeah, gosh. Yeah, there you go. Amazon are one of our big clients globally, and they've got robotic stuff all over the place. There's a lot of other people getting into it now, and we write the specifications for about 80–90% of the market. Sorry, floor specifications, not robotic specifications. Okay, I'm not going to read out all these words. I think we'll just get to the point here. Where is it? Okay. Just thought you'd give you a little bit of my background and how I became involved in flat floor because it's a lesson. First of all, I graduated from the University of Dundee in the UK about 1970 case, and with a degree in civil engineering. And I've been registered as a professional engineer in Singapore for over 34 years. Overall, I have 50 years of experience working in the construction industry, not always in floors, but in general contracting and other specialist type of activity. But for the last 30 years, I've been involved in Cobri and developing the flat floor in technology in Asia. Now, our head office is based in the UK, and the guru of our business is actually based in the UK, but he does pass on a lot of information to us. Now, it was in 1991 when I was working as a design build contractor that we were approached by a European company to build the floor, and they talked about they want to do it for a V&A. I said, well, what's a V&A? So I didn't really know. Building tall buildings, you don't do V&A in tall buildings. So it's my first experience of talking about logistical facilities. So what's V&A? V&A is a very narrow arm. All right, okay, I understand. What do you want from that? Well, the truck runs up and down the aisles, and it places pallets, and it needs a good floor. So the client said, he needs a good floor. So we said, okay, you need a good floor. We'll try and do a good floor. So we did it. We did what we thought was a good floor. We We had no specification from the client. He didn't say use this or use that or anything else. So we just did the best we could, and we had a very good solution. And we ended up with a very level floor. So we handed over, the client took it over, they used the facility for about a year, and then one day they called up and said, look, we've got a problem. And the problem was that they were using what they call a man-down truck. And the man-down truck has a camera that goes up with a pallet to place it. And this camera is very sensitive to vibration. So our floor was flat, it was level, but it wasn't totally flat. And when the machines were running up and down, the cameras were vibrating, and there was huge bills coming in for the cameras to be repaired, etc., etc. So the managing director of the company, the European company, contacted the UK and said, we've got a problem, what do we do? And they knew about Kevin Bear, concrete grinding at the time, and they contacted him and they got him to come out to Singapore. And he came out to Singapore, he measured the floor, he said, you've got a level floor, but you haven't got a flat floor. And it needs to be sorted. So he had patented a machine called a laser grinder at that time, and the laser grinder was brought over to Singapore, he ground the floor, the machine started working again, working perfectly ever since. And the big thing that came out of it all is that he and I became partners to Asia. So that was how I got into this business. But I was lucky, so my advice to anybody is, don't be the one who pays the price of failure. And I wasn't, so I was very lucky. Okay, where do we start? Alright, so the whole point is fit for purpose, so we need to give a definition to that. What something is supposed to do, how it is supposed to do it, and what standards it must meet in order to be considered successful. Right, what is fit for purpose in a warehouse or an industrial building or a logistical building? Yeah, the warehouse, the materials storage system, the material handling equipment, and the floor must act as a single interconnected system and perform optimally. So they all come together to work. The machines that they put in there, the mechanical handling equipment, they need the floor. So this is like where it's one of the starting points that we need to get established. In the next 10 slides, I'm going to try to identify most of the key people who will most likely be involved in floors which need to be fit for purpose. And in following that, I thought it'd be useful to give a bit of history on the development of high tolerance floors. Because without understanding the history, you can't understand what the problem is. Of course, there is a problem. Right, so we talk about the key people in this industry. Yeah. First of all, we've got the project sponsors. Project sponsors being the people that have the vision of what the purpose of the building and whether it needs to be high tolerance, high performance floor in any part of it. Typically, floors with buildings with flat floors, they only have a flat floor in some area of the building. It's not the whole building sometimes, especially in the office. You don't need a flat floor in the office. You need it where you need it, and you've got to decide which part of the building has to be flat. But these should start off with what we call the project sponsor. And it could be the client user, it could be a developer, it could be a logistics operator, right? They have to have a clear vision of what the purpose of the building is and whether it needs a high tolerance floor. The next set of people, and these people that's going to sponsor the project, they're people that want to maybe use the building as a facility for supply and stuff or whatever it is. And basically they'll go to a materials handling company, or they'll go to a system integrator. A system integrator is a company that specializes in integrating equipment and racking and all the rest of it, bringing it all together, working out throughputs and productivity. And these material handling people will advise the project sponsor on how he needs this building to function. And they're typically, as I said, material, pointer problem. Here we are. Right, so we've got material storage suppliers, system integrators, and MHE providers. MHE meaning material handling equipment. So they're the second set of people, and they honestly have to rely on the floor. If the floor's not right, there's not much they can do about it all. They need to come up with their specification as to what the floor should be. The last set of people are most probably the people that's sitting around this room at the moment, and I'm not quite sure how many people there are from the sponsor or from MHE, but I think that most of us out here are from the design construction part. So what is the job of the design construction team? It's to be able to interpret the project sponsor's vision, develop the brief of what needs to be done to meet the vision, and build the building such that it meets the functionality and ensure it includes any floor which needs to be fit for purpose. So we've got architects, engineers, main contractor, floor specialists. These all fit into the last category. One thing to remember is in this development that not all concrete floors require to be high performance or high tolerance, and they can still be fit for purpose. We're not trying to do floors just because we want work. If somebody can get a floor that's plus or minus 100 millimeters and it works, that's what it needs to be. So you don't waste your time on work like that. But floors are becoming more and more important with time. Okay, so as I said earlier, we talked about the history. We are going to talk about really the history behind why we've got the specifications down for flat floors. So I looked up Google and said, what does history teach us about construction? And just to give a definition from Google, we can learn from the mistakes of the past, build on the methods that worked, and repurpose old ideas to create new ones. The history of construction is endless, and new techniques and materials are created every year. So what's this? This is the first VNA, very narrow aisle machine that was developed in the 1970s. So they built this thing because of what? I'll show you in a minute. But this was the starting point to create where we're going with floor technology. So 50 years ago, that's 1970s, we're 50 years ago, when I started my career, 50 years ago in the 90s, we saw the introduction of the rotating turret truck, a VNA truck, in the US. The US were first in doing this, and this was part of the first VNA system. Why? VNA systems only need 2 meters of aisle instead of 4 meters of aisle, which is used for selective racking or general storage. This creates a 30% saving on footprint. The next one is the racking heights increased to around 8 to 10 meters, 40% saving on space. And the VNA truck could elevate the load whilst it was travelling down a very nice flat floor. It could elevate itself while it was travelling and then place the pallet, all giving good productivity. We want 2 machines, not 3 machines. We want to be efficient. And all of this improved space utilization leads to lots of savings. We do not create equipment and things just for the hell of it. We do it because there's got a purpose. And the purpose is to save money and utilize less land and all this. So, it didn't stop there in the 70s, in the VNA. At that time, in the 1970s, the first one, that first machine I was showing you there, was probably do about 8 meters. In the 80s, it went to 10 meters. In the 90s, it went to 13 meters. In the 2000s, it went to 15 meters. In the 2010, it went to 17 meters. And they're now telling me in the 20s, we're now up at 20 meters high with these machines. The floor for 8 meters is is one thing, but to do 20 meters is something else. So we need to, the industry needed to move with it. When I talk about the industry, I'm talking about the construction industry, needed to move with it. So the need for higher flow flatness increases through time, and it increases through technology, and it is driven by technical developments of the material handling equipment. And I'll add in this bit again, because I've mentioned it once already, robotics. We are not going to talk about robotic stuff today too much, because it's new, and it's complex, and we can do that another day. So we're going to deal with what we call the traditional storage systems that they have going on for the last 30 years. So continue with this what triggered the flatness revolution. Well, we needed better flows, as I've said, to make this work. Better flows need better techniques. Better techniques are developed from understanding the required specification of the flow flatness required for material handling equipment. And compliance to this specification needs better testing regimes. So, any questions so far? We're doing okay?
I think we got that one. I need some assistance. Nope, no questions.
Right, so this VNA development in the 70s led to a decision in the US to review the flatness requirements of all types of floors, including industrial, commercial, and ancillary. But it has not, I will tell you now, it has not kept pace with this since its inception. And we're going to address that one a little bit later. And again, I mentioned this one about robotics. We're now in another revolution going on called robotics. We're going to also deal with that another day. So you can see I'm streamlining the talk because it's a big, big subject. This slide shows various types of storage facilities that are being used. So quickly go through them. There's the narrow aisle, block stacking, wide aisle, AGVs, automated guided vehicles, a production line, then there's the robotics that we're talking about with Amazon, AutoStore, which is making great strides at the moment, very, very efficient system, and then ASRX, which is a crane system, automatic retrieval. So these are some, right? These are some of the systems, but they're not everything. But some of these systems are part of one of two categories. There's two categories for definition. This is the first point to take note. One is defined movement, and one is free movement. So, defined movement is like we started off talking about, the VNA. That is defined. What does that mean? It means that the trucks are sitting in one track all the time. When they enter that aisle system, they run up and down, the wheels are running in the same path, day in, day out. And it doesn't change. So the specification for the defined movement is to deal with the wheel path in front of each wheel, but also the transverse, because you don't want the forklift trucks hitting the racks and all this, and you need flatness for all that. So that's one aspect, is defined movement. I think well, it's called something different in the US. This is the TR34 British name for it, defined movement. The free movement, on the other hand, is where trucks can move anywhere on the floor. Unfortunately, due to technology of the slide system, they can only move across the page and up and down the page. But actually, we know that free movement trucks, or normal forklift trucks, can do U-turns, they can run diagonally, they can do anything they want. But we didn't manage to find out how we could do that pictorially. So this is the difference. Free movement trucks can move anywhere, DNA are stuck to inside the other. Right, so what we said was that better floors that are fit for purpose need better techniques. So I've only listed a few here, just to give you a feel for what we're talking about. So the one in the top left-hand corner, let's do a bit of a map. promoting the laser grinder, which was invented by Kobe in the late 1980s. And this machine actually can grind concrete to correct V&A aisles for the use of the V&A truck. And it can do old floors, or it can be done as new floors. So that was one machine that came out that was made choices a bit better. The second one here has actually come down below, and this is the laser screed by a company called Summerall. And I would say that this laser screed has built the most floors worldwide, but these floors tend to be on the ground floor. This is one thing we need to understand. I'll mention it now. Floors in Europe, the UK, including there, and America, basically they build all their logistical facilities on the ground floor. So we can get, you'll see the picture in a minute about that. But basically, the trucks with the concrete can come in and do direct discharge, and then the laser screed can then guide it, level the concrete out, etc., etc. is the first part of the action. And it vibrates, so it places all in one, so it's mechanized. So I think you'll see that, and that's what this machine revolutionized the industry in terms of doing bulk, large pours. There was another system, which is the long straight system, and this was also for V&A, and basically it's a way of actually setting up the concrete and casting the concrete in narrow areas so we can control the levelness across the aisleway. And this became very, very popular. We did our first floor, what we thought was the first super flat floor in Asia. We did it in Singapore in 2000. Right, 2000. So that's 24 years ago. We did that one with long strip, and it was spot on. It was an DM2 or category 1 at that time. Anyway, I'm going to skip that one down below there. I'm going to go to the one on the right, White Bay. White Bay with concrete screeders and saw cuts was another way of making floors for special conditions. I'm not going to go too much into it. The one down below, bonded toppings, is something that we developed in 2000, just after the super flat floor. It's part of the world. There are certain countries that have not so much land space. Singapore's obviously desperate for it, but you know, if you talk about doing flat floors, suspended levels and all the rest of it, Singapore and Korea must probably lead in doing these things. And the only way to achieve really proper floors in elevated buildings like level 2, level 3, level 4 is to do a bonded topping. And that means you get the floor constructed, and you get the building constructed, you close it off, and then you come back and you do a secondary floor on top, bonded to the structural floor. But this bonded floor actually gives you the floor specification. It gives you the flatness, and it gives you the soundness of what you're doing within the environment, which we're going to talk about as well. Now I'm going to come back to this one down the bottom because it's a bit contentious in Malaysia, I have to say. All the time that I have been, and maybe I should say something now, we've been doing work in Malaysia now for nearly 30 years, maybe 25 years, something like that. And we set up a company in 2008. We actually put a company in place at that point in time. But we are very well aware of Malaysia. I've done a lot of other work in Malaysia as well. But there is an issue in Malaysia where there's a myth, and that myth revolves around dry shake hardening. So in the US in the 70s, 80s, there was a very top level concrete guru called Felon. You can go on the internet and find out plenty about it. did a lot of special precast and all that. And he said, which is maybe only 45 years ago, he said, you want a flat floor? You want a good floor? Stop using dry shake hardener. I'll repeat, stop using dry shake hardener. It makes it more difficult to get a flat floor. We knew this 45 years ago, and I'm sorry to say that we have this problem here in Malaysia, that hardeners are seen to be part of the process of getting a level or flat floor. Nothing could be further from the truth. And the second part to that situation is that in certain situations, having a dry shake hardener on top can lead to other problems like delamination, right? So we can go into that one. People can ask, and the panel will answer the question if people want to know why. I'm not going to do it. It's maybe for my technical people here to tell us why. So if anybody wants to know, why? No? Okay. Maybe ask after. Right, so some nice pretty pictures here now. This is a Summerall laser screen. And it works on the principle of being laser. Oops, can I get this? Laser guided. Laser guided. So these are hydraulic rams here, and they're guided. They pick up the laser light and they keep the thing at the right level. That's the basic principle of it all. And of course, this is a beam which can go in and out, and so the machine goes down, it pulls it back at level and gives you a good level and vibrates at the same time. So it's a very quick. Anybody else wants to know exactly how it works? Again, you can go back to the technical team over here. This is for big, large pores. If you want some smaller pores or thinner pores, you can use this thing called the copperhead. This does. It's also very, very good for these bonded toppings in particular. We wouldn't use, sometimes we use a laser screed on a bonded topping, but you know, especially if it's, we can get direct discharge. Otherwise, we have to try and use the copperheads there. These are very, very good machines. Then you can see a picture up there with a Rhino power flow. These have come in and they're there to provide, to seal the surface, burnish the floor, and give you a very good abrasion resistance without the hardener. Right? This is how you get the abrasion resistance, is to work the concrete very, very hard. Okay, so back to better floors. Better floors, which are fit for purpose, need better specifications. So the floor specification in the US, because they were the ones that started all this review, don't blame the Brits, right? It's Americans. So they said, look, we're going to have a look at this. But, and a guy called Alan Face, if you look at the Face consultants, there is a connection. But anyway, it's a long, long time ago. Alan Face introduced a floor flatness numbering system in the late 1970s, which later became known as the ASTM 1155. F numbers and F numbers, and that was what was established. And this was established by the American Concrete Institute. And I'll tell you a little bit about that later, because it's one of the problems comes from that. I'm not here to criticize the ACI or the ASTM, by the way. You know, I just want you to explain to you what this all means. And since the 1979s, this specification had minor updates, but it hasn't changed the fundamental approach to it all. And a lot of times now, it's no longer relevant to what's going on. But they were the first to do it, and were first to get it into this code, and it created some improvement. But it was geared towards the people who were actually the main contractors who were laying the floors, and the concrete society, the concrete connected people who were connected into it, like suppliers and all the rest of it. So they did it for that, and that's where the fit for purpose got disconnected from it. So I'll come back to that. The second one was the floor specification in the UK, The Concrete Society developed a technical report number 34 and launched its first edition in 1988, focusing on defined movement, because that was the big thing at the time of DNA, and it spread to other elements like the free movement elements. There was another one, but it was much later, the German DIN standard, that came out in the early 1990s and then mid-2000s. So they were a bit behind, etc. Of course, in Europe, we're not following the English, and the English saying we're not following the Germans, you know. So that's how that came about. Right, so better floors fit for purpose, we needed better testing methods. So at the same time that they developed, you know, the F numbers and all this stuff, we say, how are we going to test it? We might ask we're going to do this, but then how are we going to test it? So the ACI did their bit, and I'm just going to differentiate across the top here now, and maybe I can point to it. This one, ASTM 115, FMIN, defined traffic. TR34, defined movement. Same thing. DIN 15185 and VDMA. Same thing, measuring the, well, I'm going to use this one, free movement. Sorry, defined movement. Then one down here, the F numbers were produced for random traffic flows. I know that there's around Malaysia, they try and use this system to do this, and it's not right. But anyway, never mind. Free movement, FM in the UK, so FM means free movement, DM means defined movement. And the Germans put up out there on it 202. But I'm not going to talk anymore about the German one, because again, it's another subject. It could take another hour to talk about the German one. We're going to focus on the ASTM and the TR34, because that's the ones that are used around this area. Surface regularity, what I said earlier on, I'm only giving you definitions of those so you can understand where the picture is going. These people that brought out the new specifications and new testing and all this, they understood that what affects the machines working on the floor is basically the surface regularity. And it can be divided, as I said earlier on, with levelness and flatness. So this first picture here, this is a level floor, but not a flat floor. And this is a flat floor, but not a level floor. Just to give you an idea of what we're talking about. So in the level but not flat, we're checking the flatness is property F. Just remember that, property F. And in ASTM it's an FF number. In the flat but not level, we're talking about property E. And in TR34, and we're talking about FL and the ASTM. So, any questions? Okay. Right, so we can see here is that the ASTM 1155, FF and FL, and TR34, basically I should have done the free movement. Anyway, both approaches are based on the concept of flatness and levelness. So they agree, their approach to it is to define something to do with the flatness and the levelness. And TR34 said, okay, if we're going to test the floor, of course it's all done by finding out what the elevation of the floor is doing at each point. They said, we want to test points based on modules of 300 millimeters and 3 meters. They were following the Americans, because the Americans did it early. And they were doing test points based on 12 inches and 10 feet. Because America is still imperial, and UK and Europe were very metric. So there is a connection back into the old specifications, because you can see down at the bottom here, straight edge, the old way. US tended to use 10 feet. UK had 2 meters and 3 meter straight edges. So this is all connected into the new, you're still trying to retain some of the old stuff. But if you note on the right hand, that note on the right hand says 12 inches is 305 or 304.8 millimeters. And 10 feet is 3 points. So we're actually really measuring the same way and doing the same thing. It's the interpretation of the results of the difference, not how we're doing it. So, high tolerance, surface regularity. It's just one part of it. Not only do we need a high tolerance floor, we need a floor which is high performance. So the first section is, and if you can imagine that this floor is the working platform of a logistics business. I think you were sure to pick that one up by now. You don't have a flat floor, equipment's not going to work and all the rest of it. So I was told by a building owner, might be Tesco actually, he already knows Tesco. And he said, there's only two things we worry about in our warehouse. One is the roof. We don't want it leaking. And the second thing is, we need a good floor. We want this floor to be flat because it's where we do our work. It's the main basis of our work. Most important thing. We don't want this floor to be causing any problems to what we're doing, and we want it to be there for a long time. We don't want a break. We're a 24-hour business. We don't want to be stopping work so you can do repairs and all this thing. So we want a good floor. So anyway, the first part of it, which is the high tolerance for functionality of the forklift trucks, it meets the needs of functionality. Equipment functions as intended. It's safe because if you've got bumpy floors, they're going to potentially cause accidents. And it improves the product throughput. If the machine's working at the maximum speed it can work at, it's going to give them the most productive warehouse. But high performance is different, a little bit different. This actually means a lot of things for productivity as well, but you can see the difference in it. This one minimizes downtime. If you don't have to do repairs, then you can use the building without interruption. There's low maintenance costs. You know, you put your capital cost in, you're only coming back the year after and the year after. And later this morning, Jason is going to show you a typical thing that can happen within months of building a building. And then the whole building is disrupted. There's lots and lots of stories to tell about things going wrong. Okay, again, it's like the other switch. We're also talking about the flatness and how the thing changed. So the driving of the technology to get the flatness and all this came from the equipment. But I'm going to do a little bit now on this high performance floor, right? Because nowadays it's very, very important for a lot of people. So 5 pillars to get a good floor. One, and I think it affects a lot of people here, you need to do the best design. And you take that design and then you have to turn it into detail. And let me tell you now, in flat floor technology, it's the detail that's more important than the design. That sounds a bit crazy. Should I say that structurally designing a floor these days is pretty simple. We've got computers and we can do this and do that. But knowing where to do the details properly is going to determine how good performance this floor is. So, we'll come back to that one again in a minute. Point number 2 is the know-how important material technology is. I was talking about this yesterday to Mr. Leon and his team about how we view things. And one of the problems in most parts of the world, a flooring contractor, if he wants to lay a flat floor, well, as long as he's got a good design, the next thing he needs is good material. Well, good material means concrete mix design. People don't understand that the mix design is so important as to the material that you're going to use in getting the floor flat, but also keeping it workable before you can get it all burnished off. So, it's something, if you let that control go, it's a problem. Here, main contractor will say, I don't want to let you buy the concrete, I'm going to buy the concrete. Oh, don't say you want to buy the concrete, that's fine. But you know, basically you can't tell me what the mix design is going to be. It's not, the concrete we put into the floor is different from the concrete we put into the columns and the walls. It's not the same concrete. You know, you just put it in and you vibrate and it's finished. You know, I've done plenty of it in my 50 years. But the concrete that you put into the floor has to be special recipe. Like you like your best pancakes in the world, they've got their own special recipe. If you take somebody else's recipe, you can't get the pancake that you want. This mix design is very crucial. Now, I had a job in Indonesia where I negotiated the price and he said, look, I want to, yeah, we'll finish that now. Okay, the price is okay, but I want to buy the concrete. Okay. I said, but I want to control the concrete. So you signed a contract at the same time with a rider that said, I'm going to have control over the mix design and the quality, and I will make sure that the concrete that's coming from that guy is to my quality and not the guy who's paying for the concrete. Absolutely critical to the process. Trust me. So, material, very important. These first two subjects are subject of a separate talk. Number 3, choose the right methodology and proper equipment. So earlier I showed you pictures of the laser screed and the copper heads. And, yeah. So basically, you need the right equipment to do it. So different ways of doing things. V&A, you can use narrow, long strip construction, which is a narrow wire, and basically you have to use certain types of equipment on that to get it. When you do large pour, you use those big machines, and in between you've got the copper heads and things. And there's other machines. So people need to know what equipment to use, and they have to have proper equipment. You can't have one machine and it breaks down halfway through the pour. You say, oh, what am I going to do now? That pour is ruined. So you need backup, redundancy in your process. So there are all these things you've got to think about. The next item is, you need to engage the right people who know the flat floor technology. There's nothing in Malaysia, achieving the highest tolerance of flat floors can be done quite readily. It is not difficult to do. With teaching, understanding and learning and all this can be done. Right? We've done it. We went into Sri Lanka about 3 years ago. They'd never done anything like it before. We went into Sri Lanka. In fact, the last time we went, the second time we went, we can talk about that one. The second time we went, we did a floor, and everybody talks here about trying to be difficult to get an FM2 floor. We produced a floor which was FM1. The highest tolerance of free movement. And we did it in Sri Lanka with people that had never done this thing before. So, you know, it can be done if you know how to manage it and do it. Now, the next subject is the environment. How many times have I heard in Malaysia that the people who are actually trying to make the decisions, I'm sorry, maybe some of them, apologize in advance, but if you say, no, we're going to cast this floor has to be cast in the open, and you want a super flat floor, I suggest that you go and see your psychiatrist. Sorry, right? You don't have to ask questions about this one, but you don't have to admit it. You can do that later on, throw yourself on in front of the rails. But if you want a really good super flat floor, the rest of the world out there is doing these floors in the right environment. And you guys in Malaysia are not doing that. The number of projects I hear, you want a super flat floor without the roof on, without the walls in. This material that you've just chosen, spent a bit of money on, you know, the proper mix design, it doesn't stop it from being affected by not only rain. Rain's a big problem. When rain comes onto a concrete surface, it ruins it. But you've also got wind and sun. What do wind and sun do? You're trying to get a floor to like a defined movement floor for a V&A, and you're trying to get 1-2 millimeters finishing. Suddenly the sun comes out and it's real blistering down. It will take all the moisture out and you can't get it finished at the right level. It's a problem. And we have to first of all get everybody to understand and accept that you need to find ways to stop this. Every building in the world, I think in the UK, in Europe, in America, they're trying to do a really top-class floor. They'll get the frame up. Well, we did it here with Berrington with Tesco. The whole building has to be, the frame has to be up, the walls have to be up, and there has to be no leaks coming in and all the rest of it. The thing is, to build on a building like that, if a builder can build a building at 1,000 square meters or 1,200 square meters a day, he can build his building, then we have a problem keeping up with it. But generally speaking, if you build a building and it may be a 30,000 square meter floor, it will take him maybe, I don't know, 16 months to do all that. But the floor, when you're using laser screed and you're doing pours with 35 meters by 35 meter panels, you're talking about casting 1,200 square meters a day. So 1 week, 10,000 square meters. You can actually maybe do it in, I don't know, Gary, how long?
6, 7 weeks.
6, 7 weeks, right? And that building is going to take him, 6, 7 months, right? So we can catch up easily. So there is no reason not to plan the building, to build the floor in a much shorter time, in a sequence that we can do it in proper environment. Right. Now, all these things, these 5 pillars, have to be brought together in a specification. In the handouts today, I've put in 2 specifications. One's a performance specification for SFRC floors. You won't see, you should not see any word of Cobra in it or face in it. It's a generic spec. I'm not trying to you remember where it came from, but it's a generic spec. But SFRC floors should be designed by the flooring contractor. Steel fibre reinforced concrete floors, sitting on piles. Let the specialists do it because we do it all the time. The other one, which we do a lot, is bonded topping. So we're giving you a particular specification for a bonded topping. You can specify that to the guy that's going to do the floor. But again, the development of the specification is based on what we developed 24 years ago, and it works very, very well. So, basically that specification should cover all these types of things, methodology, etc., etc. And following that, we just double back on design, serviceability, and construction. Building a floor which is fit for purpose starts with the design, I've already said this, and must be reflected in the design detail and emphasized in the specification. Most design failures is in the detail, not the calculation. Please retain that knowledge. Serviceability is a big part of this. It's critical in the context of high performance, high tolerance. Special attention must be given to key issues such as deflection, cracking, construction joints, isolation joints, abrasion resistance, skid resistance, blah, 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 blah. And I think in the handout is there, we have one laminate. What is this? This is the contents of the TR34. But it's got all the headers in it, so it's great. You put it on your desk and you say, maybe I'm at it's in section TR34. I better go and look at that and find out what it says, because that's what I need to worry about. So this is just an aid at your desk.
And just while I'm talking about that,
I've given you another laminate, which is called free movement and defined movement. This is a summary of all the things you might need to know about a floor, and gives you enough to get you started. Okay, so once you've got about your design and your detailing and your serviceability, then you're back to the construction one. So key management, right methodology, proper equipment, skilled workers, material technology, correct environment. Wow, these are to underpin the 5 pillars. So we come back to the 5 pillars. And we talked about design, so we're not going to talk about it anymore. We talked about material, we're not going to talk about it anymore. You guessed it, we're going to go around the whole lot. We're Yet another focus moment. 97% of all concrete industrial floors are used for free movement activity. 90% of the 3%, which is defined movement floors, are specified using TR34. This is for this part of the world. And customers in most cases do approach a specialist flooring contractors to do this. People have caught on to long string, not saying that they do it right and all the rest of it, that would be subject to testing. But, you know, defined movement is it's got its own way of doing things. It needs even a lot of care to get it right. So today I'm only going to focus on free movement. There's a lot to get through. Can I do that? Okay. Does the floor need to be high performance, high tolerance? Well, no. As I said earlier, not every floor needs to be high tolerance. So if you don't think it needs to be high tolerance, fine. You go and do it the way you want to do it, conventional floor, whatever it is. Just do what you normally do. Some of you might come along and say you're not right, but that's another story. It depends what your client wants. So we're now back into define movement and free movement and identify the relevant standards and choose between TR34 and ACI ASTM. So I only use TR34 here because it's like otherwise I think it might get a bit complicated. We'll show you the differences later on. So we have here on the left hand side TR34, define movement 1, define movement 2, define movement 3. And on the right hand side, the free movement, we've got free movement 1, free movement 2, free movement 3, free movement 4. Very obvious, we carry out the design taking into consideration how the floor can be constructed to the specification deemed necessary. Write the specification stating the required standards and tolerances. Specifications should address requirements for serviceability. And specifications should refer to the capability of the specialist flooring contractor. How often is that done? Okay, and after you got that done, you will go to compliance and testing. Alright, so, but we're going to drop off defined movement now. We don't want to talk about it because it's a small matter, and we're going to focus now on free movement. Okay, just to give you a bit of a global lesson on these things, defined movement on the left-hand side in Europe, we're using TR34, except in Germany, which they're using DIN, and maybe Poland as well. Then on the free movement side, in UK and Europe, we're also using TR34, and again DIN. In the USA, as you would imagine, ACI, ASTM, that's what they're using for defined movement and free movement. In Asia, defined movement, there may be some people talking about using something, but predominantly around Asia, since we've been around 30 years, we've managed to push TR34 quite well. On the right-hand side, free movement, there's a lot of countries that are using ACI, ASTM, and there's a lot of people using TR34. And I'm going to explain the difference between the two, what are the advantages and disadvantages of either. So So we're going to get rid of defined movement, so we're refining it even more. Okay, free movement, UK definition, random traffic, US definition. So the TR34, 4th edition, against ACI, ASTM. First of all, what you can see here is, well, we'll go through each point. So the first point is, the TR34 is an industrial standard for all types of concrete industrial floor. Concrete industrial floor. The ACI ASTM is a standard for all types of concrete floors. All types. Doesn't focus, narrow down, it just talks generally about all floors. Therein becomes part of the problem of needs to be updated because industrial floors have taken on a life of themselves. You know, and as I said, the robotics, it's even more critical. Let's go to the line 2. The TR34 is an informative analysis of surface regularity, measurement to fit for floor purpose. Fit for purpose floor, sorry. So basically, it's based on what they know works for that particular usage. The ACI one gives you a normative statistical analysis using various samples with sufficient confidence level. I don't know what that means, to be honest with you. But anyway, I know it doesn't work, that's for sure, because people don't know what to use. So TR34 works on property in property F, but actually it works on a few other things, which we'll point out and show the difference. But these property in property F are the same as the FFFL, which are statistical, and FFFL are statistical numbers, not real numbers. Property in property F you'll see are actually something that you can physically see and understand. The thing about the TR34 is one document. Everything about flat floors is in TR34. And in particular about surface regularities in 4 pages, all together, easy to understand, and you will see it on your card there. Free movement, what I showed you earlier. Free movement, defined movement, most of it is in there. So it's easy to look at and also focus on. On the ACI, on the other hand, you basically have ACI 302 concrete here. So there's a bit about what you need to do in every single document here. And you need to be an expert to find your way through it. And it's easy to miss out things that are key, which is often done in laziness. So we'll tell you where it's missing and why it's important. Right, so we'll go back to TR34 and concentrate on this one. So this is, now we're talking about free movement, TR34. So FM1, we have very high standards of flatness and levelness required. Reach trucks above 13 metres. So we're placing the pallets up there and they need flatness. FM2, reach trucks operating 8 to 13 metres. I would say that if you're talking about a good quality floor, now FM2 is probably the industry standard now for doing a lot of things, in particular about robotics. FM3 is lesser and lesser. So every time you go down one level, you got lesser requirement. Obviously, you got property E and property F. Now you guys don't know what property and property F is yet, but you're going to see that in a minute. But you can see that the bigger the number, the more you'll be, the less quality there needs to be in the floor as you go down those specifications. So you can see that they open up the dimensions for it. Any questions? Right, now to explain this, I'm going to take you through a very simple exercise. So I've set it up, click the button, it can show you what's going on. So basically, this floor is 10,000 square meters, and it's 100 by 100 meters square. This is something we're going to construct. This is a floor we're going to construct. Forget about the thickness of that floor. We're going to do this in 4 castings of 50 meters by 50 meters. And we've got the chart set up. What are we going to cast? As I said earlier, FM2 is a great place to go. So we're going to do FM2. So for FM2, we need property E of 6.5 and property F of 2. 2 millimeters. First rule. The floor must be constructed such that no part of it falls outside plus or minus 15 millimeters. Second one is, if a construction joint falls within a zone or area which is integral to the functional use of the floor, then all testing should be continuous across the construction joint. Does anyone not understand what that means? Just to let you understand, if I'm a concrete truck and I'm driving from here across here, I don't suddenly get to the construction joint saying, "Oops, stop." That's not part of what my truck can ride on because it's done separately. This is not what you can do. The truck's going to go from there to there. That construction joint needs to be the same as the rest of the floor. When I talked yesterday, it was like, I understand what's going on here now, so it's a bit of an issue. I will tell you, we'll show you why in a minute, why you should be using TR34, I believe, or certainly should be doing something different in ACI. Right, to explain more about the datum. On the right hand side here, the datum is the purple. Is it purple? Yeah. Datum means any of the following: reduced level, finished floor level, structural level, depending on how you want it is. But it's the level that you want. That's where the engineer, the architect, takes his pen and draws a straight line, very nice straight line, and says, "That's my floor." As we know, floors never get built to that because there's a tolerance to be done. So the floor can be like the one that's shown here, up and down. But if it goes outside the plus or minus 15, that red area, it's out of tolerance. So the first thing we need to do is to check 100% of the floor to this plus or minus 15 millimeters, the datum. The floor should be surveyed using an optical level at points which are 3 meters. Came back to that 3 meters I mentioned earlier. So we measure the points in 3 meters, center to center in each direction, but not diagonally. Just up and down and across. So you can see at the top there, you've got 3 meters, 3 meters, 3 meters, lots of 3 meters across there. So we have to measure every single point with an optical level. Then, when we do that, so all those points there are 3 meter centers by on this grid. So I'm going to go down to here. Sorry, I'll do this bit first. To check for property E, you need to calculate the difference in level between any two adjacent points, 3 meters apart in each direction, not diagonal. The difference should not exceed the limits as required for the category of floor. So property E is checked for 100% of the floor. So basically we're checking the floor 100% for datum and for property E. But we do the optical level check for every 3 meter point. We get the answer to both those questions. One, if it's out of datum, and secondly, if the tolerances between two adjacent points are out of spec. So I go down to this example down here, 3 meters apart, we measured the floor, and we now know that relative to datum, this point is -5, then it's -8, -3, +2, 0, -4, -1, +4, etc. So you can see all those points, right? Reduced level, so it's within datum. All reduced levels are not outside ±15, so it passes. Now, I go down to the next one down here, and the difference in level between those 2 points, -5 -8, is 3. It's 3. The next one is 5. The next one is 5, the next one is 2. Understand?
Yes.
So, great. So, all these dimensions down here, we all measured. And if I go, the difference is not greater than 6.5, so it complies to FM2. % of the floor has been checked for levelness and datumness. Now, we move on to the next phase, which is to check the flatness. Property F or FF when you see it in the other one. So trying to explain this one is not that difficult. Basically, what we're showing you here is where we start using the 300 millimeter. Basically how you measure the 300 millimeter, there are various ways of doing it. But what we're taking with the 300, every point, 300 to 300 to 300, we're checking what is the rate of change of gradient between those 3 points. And then we move down 300 and do it again. Now we have equipment that can do that automatically, so you'll see it in a minute. But basically, showing this one, there's 3 examples here. The first one is when we're starting at the point on the left-hand side at the top, we're starting at that point goes up 0.6. 300 millimeters up 0.6, and then the floor comes back down 0.2. So we look at the property F, it's 0.6 minus 0.2, so the rate of change is 0.8. The next one is pretty flat, but so it's not something you can actually tell you it's flat. You've got -2, and then it gets to that middle point, and then it keeps on going to another -0.2. So -2 minus -2 is 0. It's flat. You can see it's flat. The third one is that we go down the way 0.2, we hit that 300 point, and we go back up 0.5. So it's -2 minus plus 0.5, 0.7. That's the property F. All scenarios above falls within the property of property F requirement of 2 millimeters to FM2. What happens if it falls outside? It fails. Depends how much it fails. All right, as I said earlier, you need machines that can measure every 300 millimeters. This happens to be TR34. So we're actually showing you what we call the digital F-speed reader, and basically this machine is a Cobra face machine, and it basically runs on the floor and it measures property F automatically and prints it out, so it saves a lot of time. But what I'm going to talk about now is taking up the test side of things. So you've already said that datum and property is 100%, so finished. 100% flow check for those properties. How much do we do for the property F? So basically, what I'm saying here is that we want what the TR34 says. 10% of the area of the floor will give you the number of linear meters that you need to measure to do a proper sample. Minimum. So we're going to assume 12 lines at 85 meters comes up to 1,020 linear meters. That's more than what we need for the sampling. So we take the 8 lines of 85 meters and we plot them onto the area that we're going to test. And you can see that we're measuring through the construction joint. We're not stopping either side of it. That'll become relevant in a minute. And then we want to do another 6 lines that way. So we're measuring in both directions to get a good sample. Oops. Okay. All right, well that's what we sample. And we've already proved before that it passed, so it's okay. Now we're going to move on to the ACI. So buckle up. This is what the ACI and ASTM are saying. So source the ACI 117 table blah 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 refers to ASTM 1155, and it talks about these F numbers for conventional, moderately flat, very flat, super flat, and it goes into conventional mechanical rooms. It tells you a description of what they can be. So you can read on what you make of this. But if you go across to this one here, which is the ACI 302, it's a bit contradictory to it. Because in the superflat area, it doesn't talk about anything. Left blank, superflat. But as you can see, the third one, not critical, and you've got carpet. So you can see this thing is covering residential, commercial, all sorts of projects. No focus on logistics, no understanding of what logistics is doing. So people are saying, well, how do you use this? How do you specify it? Well, it's a bit of a guess. I think I'll very quickly tell this story. So what it does say inside these documents, it says that you should, if you want to get a floor that works, you should establish your own FFFL number that should be used for the building you're designing. It says it suggests that you go and find a building that's somewhere else that works, and go and ask the owner of that building, can you go in there and measure the floor and find out what FFL, once it works all right, and I want that FFL the same as that building. I don't know how many people are going to let people come into the building to do that. So the FFFL, establishing what you want, there's only through experience that it will say that FFFL building is equivalent to a FM2 or FM3. This is what's happening at the moment. So there's a bit of a fudge going on. And you can see I'm a bit negative about it, but I'm not negative. The ACI ESTM is not something that is wrong in itself. It's the interpretation and the use of it that's causing the problems. So this is what we see here. Let's assume that we can use the right FF and FL. Anything else to say on this one down here? No. Next one. All right. This specification for FFFL that everybody's punting in this marketplace, it doesn't address datum. There is no requirement for datum check on the ACI ASTM specification. And I can tell you where all this started was in America. And they built floors in a warehouse that are different TBMs, no relationship to datums. It's just a habit they got into. And it's causing problems now with logistical, with robotic projects. And that's case studies we're not doing this afternoon, I think, that's why. One other time we might talk about it, but they're not dealing with the problems it's causing. We have major things, we're doing major repairs because they're not doing these things properly. There is no requirement in the ACI to use a datum unless there's an intervention by the specifier to say, you must do to the datum, but plus or minus. They do mention it somewhere in their document, but never insist that it should be done for flat floors. How can you imagine this? So, we've got on here, put the datum in the tolerance. Right? There's no out of spec. There's no out of spec. As long as they meet property, the FL and FF spec, it's not out, there can be no out of datum, out of tolerance. Right. The second thing that's also a problem with this, all construction joints are excluded from the test area. So maybe I should explain the test areas first. Test area number, if I press this button, right. If I've got, first of all, we're dividing up into the same 4 panels as we did for the TR34. Test area 1, test area 3 and 4. ACI ASTM says all construction joints are excluded from the test area under ACI ASTM unless specifically required by the specifier. So testing, extent of test sample, 10% of the test area, same as the TR34. So we've got 10,000 square meters divided into 4, 2,500 square meters, 10%, 250, you can see the similarity, 250 linear meters, and we need to do 8 equal lengths of 31 meter per test line. So, we have to do a test in that area. And we're going to be so far back from the construction zone. And then we have to do all the other panels the same way. 1, 2, 3, 4. So, we have similar here, I use the same data as I used before. it doesn't give you this data in that way. It comes out with a statistical number. Boom, 50, gone. What does that mean? Well, it means passed or failed. If it's failed, where is it? It's really not suitable, I would say, anymore. The way they measure it is using this dipstick, which is very similar to the speed reader, but much, much slower. This is something that's, I'm not going to talk about this slide, we'll move on. Right, so property F, these test lines that we're doing, the 12, there is like, you see 8 test lines. Forget about that calculation, it's not important. Basically, we've got the linear meter test of the test area is the same as the TR, but it's in each different section. And basically, they're going to test it this way as well. They've got Q points. And again, it doesn't talk about what that Q point is, if it's too high or too low, because they're going to add all the Q points up and average it out and see what it is. But when they lay these test cases, they're only 10% of the floor. Both property FF and FL are only measured from 10% of the floor. There is no 100% coverage of the equivalent of property E, never mind the data. So basically, how secure are you when you get a flow? The second thing is that if this corner, if I just do, if this corner here has got a big problem in it, the guy just has to set the test line away from it. He's got a choice. I'm not going to measure that. It's bad. Give me a bad result. So I'm not going to do it. They've only got another slide coming up in a minute, but they don't check the joint. So they keep that back from the joint. So 10% is not a lot. And basically, where you do these test lines, if you measure it, the relevancy of that test line is only about half a metre either side of the test line. After that, it's a completely different answer. So we're only really getting about 10 or 11% sampling of the floor. And these days, it might not be good enough, and there's no joint to check. If you want to check the joints, there's a separate part of ACI that does it. So basically, they're saying that at the joint, you should measure 300 millimeters either side, which is the same as 300 millimeters before. Find out what the change in rotation is of that joint. And you do that along every joint. If you did that, that would be a better result. Somebody's got to specify what that tolerance should be. But it's never specified. It's never specified. So you can see in the summary, the ACI ASTM, if they just apply it for what they want, it suits the guy building the floor. He can make a lot of mistakes and cover them up. But you know, when you do that, when you don't do it to data, when you don't do it for 100%, when you don't do it to the joints, aren't you really getting a built floor that's going to be built for purpose? Because the equipment doesn't know it's a joint. I mean, it doesn't know that bad area over there. It's a problem. Okay, I think these points are well made. So now I'm going to tell you a little bit about the difference between TR34 and ACI in a summary. Right? TR34 is easy to use. Guidance is clear and concise. We provide 100% testing of the floor for data checks and property E. ACI, it's complicated with mathematical functions. Just press this button here. The document which is sitting there, it's in your thumb drive that's being handed out. It will it's about 8 pages of standard measurement using ASTM 1155. 5 pages of it are full of all these formulae. So how many people here have got a mathematical degree that understands all this shit? Sorry, there's one more. But it's full of stuff like this. Right? So people only look at the answer, they don't look at the method. Line 2. Define applications specifically for an industrial warehouse floor. Gives guidance and for different rack height and MHE. So the TR34 says this type of truck and all the rest of it, this is what you need the floor to be. And as it goes up in height, you need to get a bigger and better specification. The ACI doesn't cover that, it just covers generalities. You're left with somebody needing to interpret it. And I can tell you, in this part of the world, the people who are specifying, which may be you, don't know what it's all about. It is complicated, and you've got better things to do. So, again, the people are coming around saying, I can give you FFFL equivalent to FM2, blah, 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 blah. And then I started. The second part of the argument is that what they're doing is not giving you a proper test of TR34, which is what you need to do if you want to do fit for purpose. Number 3, compulsory to measure across joints. ACI, it's an option, never use it. Point 4, control data must be followed. No testing required for data packing. Case studies, I can give you quite a few. There's one recently we came across in Canada where there was a major problem with this, and basically it ended up costing the owner of the building $2 million a month. Problem. Because the guy that was trying to do the measurement and all this told his specialist flooring contractor the wrong information. He told the main contractor the wrong information, and they handed it over to the guy. He fitted it all out and it didn't work. There's a good case study in 2 minutes there. Number 5, measures the floor as a whole and looks at the relationship between adjacent panels. We had situations in the US where panel is over here and a panel, and we didn't build into the same TBM. But AutoStore wanted to go from there to there. I don't know if many people know much about AutoStore. Look it up on the internet, YouTube. Fabulous system. But it needs a flat floor, and it needs to be flat throughout. Properties number 6 here. Written and approved by pan-industry body. This is a big one. Including construction industry, the design team, engineers like yourself, property owner, and MHE experts. The working body for the TR34 is made up of everybody that's involved, all of the stakeholders in this process. The ACI ASTM was written 45 years ago by self-interested main construction people and concrete people. Nobody else is involved in it, and that's why it's a general specification for different things, as we said before. And that's why I would say that they need to update this big time. If they want to use it, big time. The reason that people use it in Malaysia and Indonesia and other places is because people can go out and buy a dipstick and go out and pretend that they're measuring the floor properly. Maybe that's a strong statement, but that's where it is, because we see so many results that don't represent what's gone. So how do you build a floor, concrete industrial floor, which is fit for purpose? So we'll come back to where we started. Identify and understand what the floor is going to be used for. Carry out the design and detailing with good principles and practice. Establish the surface regularity requirement with reference to the TR34 or ACI SDM. That's what you want to do. Choose suitable construction techniques. Develop an appropriate specification. Shortlist specialist flooring contractors with a proven track record. Manage the construction process to ensure that what is planned is actually done. Sometimes things get handed over and wait for the result at the other end. Ensure the right testing and compliance procedures are being implemented. If you don't do that, and you don't use the proper specs, you won't be able to know whether the floor that you've done is going to give you what it does, what you want it to do. This is not even, this part of it here is the performance part of it, as to whether the joints have been done properly. It's got other criteria. This is something else for another day. We can talk about that. Quite happy to come on and do another talk about design and materials and all the rest of it, because it's a big subject. Now, this next slide is very interesting. I've reintroduced the key people in this process, right? So, I've done it in a different way. So we've got the sponsors, we've got the material handling people. They're sitting up there, away from the project, because we're all involved in this bit down below. And, okay. This is something I hope many people will ask. All right? Right. Can we discuss this one? How many people, I know we've got some people from what they call client base. There's a few. I'm not quite sure where they are. I think most of you are engineers. Any QSs? No QSs. Good. We have architects. Can we have show of hands for architects? No? No architects? All engineers? Hands up for engineers. Sorry?
Everyone's shy.
Okay, anybody from material handling? No. So, the question becomes, in this matrix, is somebody needs to take overall responsibility to, if they want to drive it in the right direction. Whoever it is needs to understand what they're trying to achieve and how they can deliver it. But anyway, this is a starting point for me about just putting things out there. Okay, this, I think Mr. Leon, you maybe want to do this later this afternoon again if you want, maybe you want to talk about it. If not, no problem. We'll talk about it again. Okay, so what I've done in the handouts that I've given you, I said earlier, going round, particular specification, performance specification, free movement surveys, defined movement surveys with further exploratory information. And this is this document. Don't let anybody know you've got this because I'll get a copyright soon, right? I've taken a chance, maybe you look at it so you can see it. But that's the method statement for doing ASTM testing. And you see if you understand it, then good luck to you, you know? But this is what's being done in the market. So these are the handouts, and then I give you this handout, just in case you didn't know, the laminate. TR34 covers all this. TR34, very simple. Covers everything you see here. And then you need to do a flow. And that's the other thing I've given you on the laminate. You can see quick tables, and quick guide, and all this. So it's just a handy thing to have around when you're thinking about things. Thank you.
Okay, thank you very much. We will now go for a short tea break. I'll cut this slightly short, maybe about
getting the right level of support from the main contractor. That's really important to us. And then the compliance and performance test, I put that as a separate item in here because that's how important it is to get a good floor that's fit for purpose as an end result. And then the focus of this case study today, the other thing that can go wrong is everything. It's a rare case, but sometimes everything goes wrong. So this is this case study when everything goes wrong. This is a recently completed multi-story ramp-up warehouse at Korea, the floor area is more than 150,000 meters squared. Yeah? In the last 5 years, there have been a lot of warehouses of this size or even bigger at Korea. This is not a new project or new design. There's nothing special about this project. For whatever reason, it's just gone wrong. It's mainly a precast structure with some PEB steel on the top as well. It's quite common in Korea. Just before I move ahead with this case study, I should also explain that, like I said, this is a normal type of warehouse in Korea. Most warehouses follow this similar design. They don't have issues, they get done right. Whatever reason it is, this project has gone wrong. The problem, within months of the logistics operations commencing, widespread floor defects have occurred throughout the floor. The tenants, both of whom are market leaders in the industry of Korea, are obviously very concerned about the short-term durability. Forget the long-term durability, the short-term durability of the slab, and have demanded immediate action from the owner. So the project brief. Actually, the development was acquired on completion by a global real estate investment and asset manager without due diligence carried out to the floor slab. That's perhaps the first mistake. Subsequently, when the defects became widespread and the tenants started complaining, the new owner invited Face Consultants Korea, or engaged them to carry out a preliminary floor inspection and condition survey to find out the cause of the problems and try to understand what's going on and the risks, but only to the 50,000 meters squared ground floor. The upper floors have their own problems, but the ground floor has got the most serious problems in this development at the moment. Quick look at the slab design. Basically, power trial finish. Very often in Korea they use liquid hardness. We don't fully understand why. They seem to like it. This is straight out of the architectural drawings, by the way. This is designed as a 250mm slab on grade. Okay, SOG. It's got a very thin layer of plastic sheet below it. And then it's also got a 100mm layer of urethane foam insulation. We don't know the function of this. This is not a fully enclosed basement. It's not a cold store. It doesn't really need that urethane insulation foam. Okay? And like I said, this is straight out of architecture drawings, and it's clear that the design intent was a slab on grade, SOG, otherwise known as a ground supported slab. We'll call it an SOG in this case study. So, let's quickly look at the concept of a TR34 ground supported slab on SOG. One is to ensure uniform slab support, which should result in minimal settlement and definitely must prevent differential settlement. That's the worst thing that can happen. Obviously, if there's any doubt about the soil conditions, you need to involve a soil expert. We are not soil experts. Now, one way to check the soil is the right condition for slab on grade is to do a plate bearing test such as this. That will not give you an indication of long-term or even short-term settlement, but we used the output of this, the K value, in the design of the slab on grade. But it will also give you an idea on the consistency of the soil as well. It might show if there are any concerns or risks. As you can see on the right here, this is a good example of a good slab on grade floor construction in Korea. As you can see, the concrete tracks are directly discharging the concrete, and during the floor construction, that sub-base layer below the concrete is stable, no deformation. The second key point, concept of a slab upgrade is to avoid unplanned cracking by allowing the concrete to shrink, talking about dry-in shrinkage, or concrete as dry-in shrinkage, without restraint. Yeah? So you can see in this good example, we have a saw cut joint, and below the saw cut joint, it has induced a crack. That's exactly what we want from saw cut joints. Yeah? TR34 refers to this as a sawn restrained movement joint. Yeah? So this is what you want. Now, if that saw cut was not deep enough, if that saw cut was applied at the wrong time, the concrete's too hard, if there's too much reinforcement going through in that slab, it is not going to induce the crack, or the crack is not going to open. So it's going to fail. One point to consider here, a saw cut joint is a planned crack, but a crack in a straight line, so it's easy to maintain and it looks better. That's simple. Also, when we talk about trying to avoid restraint shrinkage, we've got to take care of columns. There's a good detail around the column, so it allows the concrete to shrink around the columns. And then construction joints are very important. You can see a good example here of an armoured free movement construction joint with dowels to transfer the load across the joints. That's after 1 year, you would expect that joint to open up by maybe 20 millimetre. That's good. Consider if that joint didn't open up by 20 millimetre, that would be 20 millimetre of cracks within that panel. Yeah, you don't want that. That's the benefit of this system. Any questions at this point? Any questions related to slab upgrade floors? Any questions for me?
No, it's fine.
Okay. So what went wrong? Yeah, let's take a look at what went wrong. First of all, there was no performance specification. During the floor investigation, we looked at all the as-built documents as a new floor. There was no detailed floor specification. There was no clear performance requirements in terms of floor flatness or levelness. And TR34 is the basic standard for warehouse floors in Korea for many years already. So there's no excuse. So surface regularity, TR34, yes, we look at flatness, we look at levelness, and very important, we look at departure from datum, and with robotics, that's also becoming more important now, as Colin mentioned. Typically in Korea, a ground floor slab would be specified to TR34 4th edition FM2. Upper floors, sometimes you've got challenges to achieve FM2, and you've got lower ceiling height, so FM3 is quite commonly used, still challenging to achieve. Sometimes the owner has specific requirements, so the upper floor will also be specified as FM2. Now the second performance, very important performance requirement for a warehouse floor is surface abrasion resistance. Almost every modern warehouse floor in Korea has surface abrasion resistance, or AR specification, with testing. Very important. Concrete quality in South Korea is actually very good. So why is this needed? Well, first of all, when you've got a multi-story warehouse floor, you cannot always control the environment. Sometimes the building's semi-enclosed, so you have to consider the environment. That's going to impact the surface abrasion resistance. But also at Korea, it's very cold in the winter. It can be down to minus 20 degrees C. And main contractors under too much pressure, they keep going. So there are sometimes abrasion resistant problems at Korea. This is an extreme example of a floor with an AR problem. This is not Korea, this is somewhere else. And obviously it's a serious problem, as you can see. That's actually caused by a small logistics robot, turning an AGV or AMRs into known, turning around in the same location 24 hours a day. That's the damage MHE can do to a concrete floor if the concrete's not right. So the equipment the top right-hand corner here, this is AR testing equipment according to British standards specification, which is also a European standard. It's basically accelerated abrasion resistance tester. It's got hard steel wheels which rotate very quickly a fixed number of times, and you then measure the depth of wear to the concrete. So typical specification in Korea would be AR1. AR2 is also okay for most warehouse floors. So for AR1, the maximum depth of wear during this test is 0.1 millimeter. So, failure by design. The architectural drawings for this project refer to the ground floor slab at B1 as a slab-on-grade SOG. Yeah, as you can see here. No details provided, just a typical section. The structural calculations refer to the ground floor slab as FS1, also SOG. You can see it's stating the same bearing capacity there, but it's also showing two layers of reinforcement bars, HT13 and 200, top and bottom. Yeah. However, the structural drawings also include a detail showing the structural connection, FS1, slab on grade, to the beams, plus a concrete pedestal all the way around the edge of the slab. Yeah. So, the question is, the point is, the design intent is not clear. It's connected to the beams and parts of the structure. Is it designed as a ground supported slab or is it a suspended slab? Not clear. Okay? And as you can see from this photo during the construction, the slab is also supported partly on the column foundations and partly on the soft insulation foam. It's definitely not uniform support, is it? So how does TR34 define a ground supported slab? Ground supported slab is a floor supported on original or improved ground where universal, uniform support from the ground is assumed. Like I said, it's clearly not the case in this time, but on this occasion, the design concept is not clear. The risk, differential settlement. It's a big risk. This is all not right. This is an extreme example. Again, this is not South Korea, but that's what can happen when you've got differential settlement in the slab on grade. It's a disaster. The second big failure by design point with this, or defect with this floor that we saw, is widespread cracking throughout the whole floor. At places up to 1 to 2 millimeter wide cracking after 6 months. This is structural cracking, clearly. As you can see here, they put saw cuts in the floor, but they've still got cracking. So they've got double the amount of cracks in the floor, basically, double the amount of maintenance. What's the probable cause of these cracking? Most likely causes are either settlement or differential settlement, or restraint to dry and shrinkage. We think probably this floor is a combination of both. Yeah? Difficult to confirm, of course. Just going back to this urethane foam, we really don't recommend this spray by type. It's most coastal floors at Korea actually use this type. We're fighting against it all the time. It's just too soft. The test report for the insulation foam on this project indicated the compressor strength to be 15 newtons per centimetre squared. This is below the recommended strength to provide an equivalent K-value for a slab on ground floor. Risk and concerns? Yeah, it's low strength, you've got a risk of compression or settlement. This spray type foam is also very difficult to apply, flat and smooth, which we need to avoid restraint to dry and shrinkage. Yeah? So more often than not, when we're involved in a coastal floor career, we end up asking them to cut the foam, make it flat. It takes them a long time and a lot of money. Recommended insulation type is XPS, extruded polystyrene from the boards. And you can see from a leading supplier here, they're suggesting for an industrial floor something of strength, more than 3 times the insulation on the applied to this project. So the design reinforcement was top and bottom, HT13 at 200mm spacing. These as-built drawing photos during the construction clearly show someone decided to change that reinforcement during the floor construction. Yeah, this slab grade might not even be considered a structural slab in the design codes. So, no, who decided to change this and why? We have no idea. And they put all the reinforcement in the top. Obviously, that's a problem if the floor is going to deflect. Yeah. So the slab reinforcement ratio here is 0.53%, considering 1 meter cross-sectional area. Why the design change? What is the purpose of the reinforcement? What's the function of the saw cuts? What if the saw cuts cut through the reinforcement? Many questions, many concerns, many unknowns. TR34 is very clear. It states, load transfer is provided by the fabric reinforcement across the saw cut joint. The steel area is typically around 0.1% of the slab cross-section. Very importantly, TR34 also gives a bottom limit to ensure suitable load transfer across the saw cut joints. It also gives an upper limit to ensure that there's not excessive reinforcement which might restrain the shrinkage. 2 is the saw cut cuts through the reinforcement. That's going to be a disaster because you're going to have curling and many other defects. Let's take a look at that photo. So surely, if a specialist flooring contractor with experience was involved in this project, they would have immediately said, no, this design specification is wrong, this needs fixing. For us, we would have probably said no to doing this contract. We just wouldn't have done it. It's too much risk. This is a photo taken during the floor construction. What we can see here, a couple of things. One, the direction of the concrete placement is wrong for this methodology with a copperhead laser screed. It's going to result in floor finishing problems. Secondly, as you can see here, the concrete sample is just way too wet, just too wet concrete. You can't make a flat floor with this type of equipment with very wet flowing concrete. Concrete mix design, concrete needs consistency, needs control. So our conclusion is that this team constructing the floor is 2 separate companies. Yeah? There'll be a floor finishing screeding subcontractor, excuse me, and there will be a concrete placement subcontractor. This is a very traditional way of constructing floors in Korea. Yeah, so clearly not a qualified specialist flooring contractor. As Colin said, who takes liability for defects? Not clear. Yeah, the owner wants single point liability when defects occur. Procurement is critical. Compliance testing for floor flatness levels is also critical. The owner should pre-nominate a specialist testing company. Yeah. For this project, the upper floors were tested to FM3, third edition FM3. Okay, and you can see a photo here during the testing. Is this a qualified testing company? We don't think so. Why? Well, property, TR34 is very clear. Property E should be measured using a precise level and staff. This floor has been surveyed using a laser with to the nearest 1 millimetre. Yeah? If the limit is 6.5 millimetre, you can't just round up results to the nearest 1 millimetre. It doesn't make any sense. We don't think this is a qualified testing company. Yeah? This is the correct way, according to TR34, of surveying to property E, TR34. Let's move on to the construction issues. Yep, as you can see, construction joints are the biggest maintenance concern in any warehouse floor. In this warehouse, in this project, total failure of the construction joints. It's a disaster. Yeah? And if you look at the construction of the construction, they're using a very old traditional method of construction joints. It's just not going to work. So what's gone wrong here? Well, one, as you can see, the reinforcement bars are continuous through the joint. It's restraining shrinkage. The floor can't shrink. Secondly, the steel L angles used to control the levels have been cast in place. So it's very simple. The concrete cannot shrink, so it wants to crack. And it's just going to crack at the weakest point in the floor, which is above the joints. We don't know how to fix this. This is a total failure. These construction joints really need removing and reconstructing the whole slab at the joints. It's a big job. So saw cuts have been cut into the floor, but at 3.3 by 3.3 meter spacing. Why? No. Perhaps it was driven by material sales company, or we don't know. But TR34 is very clear. Typically, slabs cut into 6 meter panels. The joints can be expected to open by 1 to 2 millimeter maximum, if everything works out well. So, we've got 50% of the recommended saw cut spacing. So we've got 50% more joint length to maintain on this project. But then the saw cuts have failed. So you've got saw cuts plus to maintain, plus cracks to maintain. Yeah? So this problem is going to have continuous, ongoing durability and maintenance concerns. It's very clear. Other construction issues, surface delamination in places. This is the worst thing that can happen to a flooring contractor. There's poor finishing, weak surface. You can see the texture on the floor here, and that's why the floor looks so dirty after 6 months. We've also got excessive crazing cracks in places. Crazing cracks are not really referred to as a defect. It's really a natural property of power-troweled concrete floors. But if the concrete surface is very weak, then the crazing cracks can also cause problems, maintenance of the floor. So, summary and conclusions. Let's take a look. First of all, Face Consultants was requested to carry out a random FM3 floor survey. Just to begin with, just to a 2,500 meter squared floor area of the 50,000 meter squared ground floor slab. You can see the results here. This is difference in elevation on a 3 meter grid property E. The yellow points are the failure points, basically, where the difference is more than 8 millimeter for FM3. The bigger concern is the greatest difference in elevation over 3 meters is 20 millimeter. That's going to be a problem. We can also see the control of the datum, even in this small flow area, fails the maximum 30 millimeter, plus or minus 15 millimeter required by TR34. Yeah? this is a 50,000 metre squared warehouse. I don't know the difference in levels over that area, but it's going to be a lot. Yeah, it's going to be a problem. Face consultants also carried out AR testing just as a random sample of 3 floor locations. As you can see, all 3 locations have failed to achieve the requirement of AR1 in one place by a long way. Yeah? And there's a big variance in these 3 readings, big variance, which tells you there was a lack of control over consistency of the concrete. That was clear. That's clear from these results. Yeah, and that's the result of AR testing. Yeah, it's a serious problem. And again, this is not a simple fix. You can, a floor fails AR like this, you can't just grime, polish, and put some liquid on it. It's not going to do anything. This floor needs a major renovation. So, what about remediation? Could do a temporary repair, but you know, if we do temporary repairs, you would have significant continuous repairs. You're going to be doing annual maintenance throughout the floor. A lot of disruption, a lot of downtime. The tenants are going to be moving out. They're not going to be happy. Permanent repair. The floor's only been used 6 months. You know, so how to permanently repair this floor? There are defects throughout the floor. We really don't know. Worst case scenario, either some areas or the whole floor might need removal. This floor's going to get worse very quickly. It's clear. So, yeah, the cost of this floor is going to increase very rapidly, and the owner's not going to be happy. So let's go back to what Colin introduced in detail earlier, which are the 5 pillars to get a good floor. Quick reminder: best practice, design and detail, understanding material technology, especially concrete, reinforcement, construction joints, selecting the right methodology and the correct equipment for the specification, for the client's or end user's requirements for the floor, selecting a specialist. That could be a specialist consultant, flooring consultant, and a specialist flooring contractor. Could be a design and build contractor. Choose someone with a proven track record. And then controlling the environment. For me, when I talk about controlling the environment, it's not just stopping wind, rain, sun, entering the concrete, what you're placing and finishing it. It's controlling the site conditions. Yeah, if you've ever been involved in a multi-story warehouse project, a big project like this, it's difficult to control the site conditions. We need good support from the main contractor to make a high quality for the project like this. So let's look at the summary of defects and also compare to these 5 pillars. Can we minimize the risk of these defects by applying the 5 pillars? Let's take a look. 1, this is not a cost-effective design. This is very clear. Yeah? Engage in a specialist, better methodology, better control of materials, detailed design specification. The cost of this floor would have gone down, not up. That's clear. Especially considering long-term maintenance costs that are going to result. We have a future risk of differential settlement. Again, most of these pillars can control that. We've got widespread structural cracking. Yes, combination here, we can control that. Failure of construction joints, same answer. Surface delamination, the environment as well is a factor on delamination. You want to prevent the wind, rain obviously, and sun and so on. We've got additional maintenance costs from the saw cuts. That's basically a design specification issue. But again, a specialist flooring contractor, if he was honest, would say no, this is not the right way. Failure to achieve the required floor flatness, levelness standard, all of these 5 pillars can impact that. That's obvious. Same thing for floor finishing quality, same thing for abrasion resistance standard, which has failed. It's very clear, these 5 pillars can control the overall quality and of the floor and give a good value engineering solution, which is cost effective and meets the owner's specific requirements for the floor. So, how could it or should it have been done, this floor, according to the other floor? This is the slab design applied. We very, very rarely, if we're doing design of a warehouse floor, unless it's very, very high loading, we would not need a 250mm slab or grade. Just unheard of, almost. So this is a typical detail design according to TR34. First consultants also using the same design concept. As you can see, typically the minimum slab thickness would be 170mm. It's sitting directly on a 0.3mm slip membrane and a 200mm sub base, which is basically well compacted granular material, and that needs to be constructed as flat and level as possible to allow the floor, the concrete, to shrink in that first year. Yeah. The steel fabric, we've used one layer of steel fabric reinforcement, a secondary reinforcement, and because it's not structural, we put it at the bottom. Top of bottom is not really important here. And these armoured construction joints with dowels transfer the load across the joint. So the reinforcement does not go for that joint. That's how the dry and shrinkage will focus on these construction joint, armour joint locations. Yeah. Below you can see the saw cut detail. The steel fabric reinforcement goes through the saw cut joint location, but because it's followed the limits on the cross-sectional area of reinforcement as per TR34, this saw cut will function. It will open up maybe 1mm or so. Yeah. This is the correct way of doing it. Yeah. And very clearly to everyone, that floor would, initial floor construction is probably 75% of the actual floor that's built. That's without considering the ongoing maintenance repair costs of this floor. Yeah. So, very clear conclusion, a high quality floor designed correctly, built by a specialist, doesn't need to be an expensive floor. Now, this design will also allow a very a simple floor construction method, fast track solution. We construct the joints, we install the joints and level them as the concrete is being placed. Direct discharge of concrete. We can use a full-size laser screed so we can make a flatter or level floor. Far more simple construction method. And that's a result. Yeah. A floor, and well, you can see the owner, which is BMW here. When they moved out of this warehouse floor to their new DC after 10 years, we asked them, you know, and we constructed the floor. How much maintenance did you do to this floor? How much money did you spend? And why didn't you call us back to help you with the maintenance of the floor? And they told us, for 10 years, they didn't spend any money at all on the maintenance of this floor. Yeah, so we got a second project. There are many defects that occur in glass floors. Weak surface, joints, delamination, failed joints, curling, and yeah, serious problem with that one there. Okay. Many things that can go wrong. The good news is, by focusing on providing a floor that is fit for purpose, most of these defects can be either minimized, all of these defects can be minimized or prevented. Yeah, it's not complicated. It's just following basic standards, best practice standards in construction industry. It's not rocket science. One, identify and understand what the floor is going to be used for. Listen to the client, listen to what they want, how they're going to use the floor. Two, carry out good principles of design and detailing. Use a specialist, always recommended for warehouse floors. 3, establish the surface regularity requirement with reference to TL34, or if you do it correctly, insert it correctly, no problem. ASTM is fine. Don't over-specify. We don't need to over-specify. We listen to the requirements for the client. Choose the suitable construction technique and methodology. Develop an appropriate specification without over-specification. Procurement, shortlist the specialist flooring contractors, select companies with a proven track record. You can keep the cost down by obviously having a competitive tender, as long as those companies are qualified. And then manage the construction process. Again, basic standards of QA/QC throughout the whole process. And I say again, good support needed from the main contractor. Finally, ensure the right testing and compliance procedures are being implemented. Yeah? This is not rocket science. It's basic construction best practice, as I said. Yeah. Conclusion. Any questions? No? That's my very good presentation. Any questions, Colin?
No, I think I understand.
Thank you very much.
The very last topic will be tile adhesive by Celia from Lkl. And a small note, before everyone leaves, for those who are driving, the QR code, please scan the QR code. After you scan the QR code, you are supposed to type in your number plate. The flat rate for parking for the basement parking will be 10 ringgit. All these QR code will be on each of the bar tables outside. So any of the QR code you can scan, put in your number plate. There's no time period to it, you can scan anytime. Then flat rate 10 ringgit, you can pay either e-wallet or your card. So all these will be left outside. Remember to pay before you exit. There will be no machine, there will be no operator, all by QR code. So we move on to the last session. Celia, back to you.
Good afternoon again. We see still a big crowd still staying. Thank you. Okay, the last topic on tiling solutions. We'll start off with understanding tile adhesives, applications, and then tile grouts. and we also touch on movement joints, some common defects around tiling, and the types of tile adhesives and type of tile grouts, followed by protection of the finishes, and we wrap up with a summary. Alright, tile adhesive is actually a bonding bridge between the tile or stone and substrate. Yeah, and is available in cementitious, organic, and reaction resin based. Tile grout is a colored filler to fill the gap between tiles, and is classified into cementitious and resin types. And it is and then for movement joints is an intentional interruption in the tile or stone surface to allow for movement for the wall or floor. This is to cater for building movement or thermal expansion when it's exposed to sun and rain. And with movement joints, it also helps to minimize occurrence of tile cracking and debonding. So a tiling system comprised of different components. You have the substrate, a tile adhesive to bond the wall or floor tiles or stone, and then a tile grout to fill the joints, and then also movement joints if we're looking at large areas. All the components are equally important and interconnected. So it's important that we look at each component when doing an applications to ensure successful tiling. And proper installation and quality control is essential on site too. So what is tile adhesive? And we start off by selection of tile adhesives. It is important that we select the right tile adhesive, as there is no single formula of adhesive that fits all types of stones and substrates. So the size of the finishes, whether if we are looking at bonding small little ceramic tiles or whether are we looking at large format tiles meter by meter, that determines what kind of adhesive that you need to use, the type and characteristics of finishes. In the olden days, we have ceramic tiles, and as we advances, we have homogeneous natural stones, man-made stones, glass mosaics, and now agglomerates. Yeah, and the area of installation, whether are you tiling in a toilet or whether in a balcony, whether you're doing in a swimming pool, which is in submerged condition, or whether you are doing in a driveway, yeah, where it is subjected to vehicular traffic, or whether you are looking at a fast track option where you are doing a refurbishment in a shopping mall, which means that you tile at night and open the next day. There are so different criteria will require different types of tile adhesives. And what are the substrates? Are we looking at common mortar, steel, drywall, etc.? So a drywall will be different and will react or behave very differently from a piece of concrete or steel. And then understanding the compatibility with other related materials such as stone impregnator or sealer. Nowadays, it is very common that the stone is treated underneath with an impregnator. Yeah, so we also have to understand what kind of impregnator was used to treat the underneath of the stone before we can propose and recommend or select the right tile adhesive. And lastly, understanding the working properties and limitations of tile adhesives. So in the market, very commonly, one of the classification and specification that we depend on to select tile adhesives is the EN 12004. It has different criteria, and if you look on the left, you can see the CETSF. These are category to determine on the performance level of the adhesive. So example like C1, if we say that we have a C1 tile adhesive, what does it mean? It means that the adhesive has an adhesion strength of at least 0.5 megapascal at 28 days. Yeah, I will not run through all the requirements. I'll just pick some important ones to highlight. And then you have this transverse deformation, which is represented by S. This refers to flexibility, how flexible the tile adhesive is, and it is represented by a S1 or S2. So meaning that when the tile adhesive is able to deform up to 5 mm, meaning that the adhesive is flexible and it will have an S1 class. And for highly deformable tile adhesive which can bend more than 5 mm, it will have an S2 class. So when you read into the tile adhesive product data sheets, you will be able to see some of these alphabets classification. Yeah, and that will help us or guide us to select the right tile adhesive for the application. So for like just now I mentioned, for the S class, it is important for areas with high traffic movements. Yeah, when you do it in a trafficable area, you cannot use a very rigid C1 tile adhesive because firstly, it will not have sufficient bond, and secondly, it will not be able to flexible. It will not be able to accommodate the movement when the vehicle passes over the tiles. So some definitions on working properties of tile adhesive pertaining to the characteristics. Pot life here refers to the amount of time which the adhesive remains usable after mixing. Meaning after you mix a pot of adhesive, how long can this pot remain workable? Yeah, that refers to the pot life of the tile adhesive. Some tile adhesive has a pot life of 30 minutes. Some has a pot life as long as 2 hours. Yeah? And you can find that on the technical data sheet. Open time is a very important criteria when you select tile adhesive. This is the time which the tiles has to lay over the adhesive before skinning occurs. I will elaborate this in the later slide. And then adjustability here refers to the time allowable for you to adjust the tiles after you have placed over. Ready for traffic here, meaning time required for the adhesive to set before opening to foot traffic. And then grouting, once it is able to step over, then you can do your grouting works. And cleaning. After you put down the grouting materials, you need to clean off the excessive grouts that is left on the surface. So if you look at the, I think picture speaks louder than 1,000 words. So when you talk about pot life here, right, see the bucket with the adhesive in there. So after mixing, how long does this adhesive, this mix in the bucket, how long can it remain workable? Open time here refers to when the tiling trowel the adhesive on the wall. How long can the adhesive remain wet without skinning? So how you can test it is you can actually lightly place your finger into the tile adhesive and you lift up your finger. If there is no adhesive adhered to the finger, that means that adhesive has already gained skinning. And when this happens, right, if you put a towel over, you will have very little wetting at the back of the tiles, and this can cause debonding or hollow something. Yeah, so we recommend you to do a retrowel, break the skin before you put the tiles over, yeah, to gain the bonding. Okay, setting time here refers to the drying or the curing time of the adhesive before other works can be carried out. So for a normal set system for screening, it takes 7 days for every 10 mm thickness of screen, yeah, to cure before tiling can work. And then for tile adhesive, initial curing is 24 hours before grouting works can commence. If you are looking at the rapid setting system, initial curing of screeds can be as quick as 24 hours, and foot trafficking in 2 hours. And for tile adhesive, when you're using a fast set tile adhesive, you can actually do grouting after 2 to 3 hours. So it makes it save a lot of time when using rapid set system, but at the same time, it is more costly, yeah, with the rapid set system. So when we look at application, again, moisture content of substrate is an important factor to consider. Make sure that the substrate is fully cured and there is so that it minimizes moisture movement from substrate through the joints and prevent debonding and staining of tiles. We recommend a surface moisture content of anything below 6%, yeah, before tiling can take place. So when you do tiling works, first notch the adhesive on the wall, on the floor or on the wall, followed by back puttering, and then place the tiles over the floor that was troweled with the adhesive, and give a light tap using a mallet to achieve a good contact with the adhesive and the concrete. So a good practice is to check for coverage. Yeah, once, especially for large format tiles, we want to make sure that the coverage of the adhesive is sufficient. So what you need to do is, after you lay the tiles over, lift up one piece of tiles to check whether the adhesive has sufficient coverage. So if you are doing tiling over in dry areas, we are looking at least 85% coverage, meaning 85% of the area of the tiles must be covered with the adhesive. Yeah, for wet areas or submerged condition, we are looking at least 95% coverage. So this is a poor coverage when you lift up the tiles. Yeah. So with all the boson, when you do the tap test, you need to hear the sound, the hollow sounding test, the hollow sounding after tapping. And if this is not repaired or not, and if it's not retiled, you are likely to fracture when subject to impact. So this is showing good coverage with at least 85%, and the tile is almost fully bonded. And next, check on leverness. Check the evenness and leakage after laying tiles. And you can do so by putting in plastic spacers to control the level and also to control the grout joint width. So understanding the tile adhesive specification under EN 12004, there is also a specification for tile grout. Yeah, under EN 13888 and ISO 13007. So this gives a criteria for tile grouts that is suitable as a grouting material for filling up tile joints. So for selecting the tile grouts, right, in the technical data sheets, you should be able to see the classification of the tile grout. Like just now I mentioned for tile adhesive, if you look at EN 12004, you can see that some tile products, tile adhesive products, has a classification of C2TE or C2TES1. So with this classification, it gives you a guideline to compare between different tile adhesives. Yeah. Likewise, for tile grout, you have CG1, CG2. So depending on the compliance of the characteristics that you see in this table, when a product complies to item 1 to 6, it will be given a classification of CG1. But when the product also meets the additional characteristics, it will be classified CG2. Yeah. And this is the working properties of tile grout for epoxy, and you will see that they are classified as RG, not CG. Yeah, it's resin grout. Okay, movement joints. This is something that is important and I feel that is close to our hearts. Yeah, movement joints is a factor that also affects or cause defects on site. Movement joints are provided to accommodate movement in large continuous finished areas or between adjacent building components and dissimilar substrates. So this is reference from CP68, where it gives you a guideline on the distance between each joints and how wide is the joint width. So when you have structural movement joints, right, you have to coincide with the structural joints on the concrete, and then as you lay the tiles, and the minimum joint width should not be less than existing structural joint width. And where tile stones works abuts restraining surfaces such as perimeter walls and columns, beams, for in interior wall and floor, you see that the joint width is about 3 to 5 mm, and for exterior is 10 to 12 mm. And if you are looking at external floor and wall, it is recommended to have 3 meters spacing at joints with 10 mm wide and 5 meters spacing for joints with 12 mm wide. And then we have this effect of temperature change on floating screeds. Yeah, so if you do not have sufficient joints, then that gives you no space allowance for movement, and ultimately what you end up with is a buckling, yeah, due to lack of movement joints. So you can either include movement joints based on the guidelines in CP68, or you can also include what we call perimeter joints. That is perimeter to install movement joints around the perimeter of a room. So this was adopted in some of our residential projects, yeah, where buckling tiles buckle due to movement, and what the contractor did was they actually included joint perimeter joint in each room, yeah, so that when there's movement, the joints, the perimeter joints will help to cushion the movement and eliminate the tiles from buckling and bonding. So what you need to do is cut a strip of joint filler board about 100 to 150 mm and apply a thin coat of adhesive. And then you stick it around the perimeter of the wall. And then do a casting of the cement sand strip and do a pre-cut on the joint filler about 3 to 5 mm above the strip level. Do not cut through the joint filler, yeah, just cut about 3/4 depth of the joint filler so that it still stays in one piece. Apply the tile adhesives and then lay the tiles. And then strip off the cut portion of the joint filler. Because we have done the pre-cut just now, you can just lift and remove the top section of the joint filler, and that leaves you a gap between the adhesive and the tile, which you can put in a sealant. So this sealant is placed in to accommodate any movement within the room. And lastly, install a skirting, yeah, to hide the sealant. So this is one solution if you have popping tiles in the building. So some common defects relating to tiling, and the common causes of debonding could be due to inadequate provision of movement joints, incompatible tile and bedding material. Like just now I mentioned, if the back of the stone is treated with an impregnator, yeah, then you have to understand, or you have to conduct your own internal test to ensure that the adhesive that is used to bond the stone is compatible. Yeah, or the concrete or script is not properly cured or incorrect installation practice is done. Example, the tile is placed over the adhesive over the open time. So this is a case study, popping tiles in residential. About 2,000 cases of dislodged tiles reported in 2016 and 2017. Due to differential thermal expansion or contraction of the tiles or change in temperature adding more stress beneath the tiles. And how to prevent this? Yeah, firstly, make sure that substrate preparation is done correctly. The tiles, the back of the tiles is clean before placing tile adhesive. Make sure that the tile placement is within the adhesive open time. Make sure you do not apply, do not put the tiles over the adhesive when it has already skinned or past the open time. And then if you know that if you are experiencing popping tiles in your unit, for example, you may want to install perimeter joints, yeah, and then check for hollow sounding at the end of the installation to make sure that you have sufficient coverage. Efflorescence is something that we see very often on site. Yeah, so it really depends on the material used and the installation method. So here we are looking at a wet mortar that is placed on the concrete and the stone is placed over the wet mortar. Sometimes in this method, right, you may sprinkle cement and some polymer on top before you place the stone. But by doing that, right, it can create weak adhesion strength, and this wet script can cause watermarks and staining of stones. Because when you do wet mortar, most of the time, if you are using in situ mix, then the question is how clean is the sand? Yeah, if the sand contains soluble salts, then it can give rise to efflorescence through the grouts, through the pointings. And excessive water may cause efflorescence at joints and marble veins. So you may end up with situations like this, watermarks and efflorescence through the tile pointings. And when dealing with moisture sensitive stone, this is another class of finishes that require special attention. Yeah, this type of stones may warp due to contact with moisture. So what happens is when you place these stones over a bed of adhesive, the stone starts to suck water from the adhesive and it causes warpage around the corners. Yeah, and eventually there will be debonding, and then when you do the tapping test, you will find hollow something. So we'll touch on the solutions later. And then you have leakage caused by warping of compressed quartz. This is also caused by warping along at the four corners. And the solution to moisture sensitive stone is to use a rapid setting tile adhesive, yeah, or a resin adhesive like epoxy adhesive. Yeah, so why fast setting tile adhesive? Because with a fast setting tile adhesive, it will accelerate the hydration of the adhesive and it holds the stone before it starts to warp. With a normal set adhesive, it has a longer setting time. So before the adhesive gains strength, the stone has started to warp already. Okay, so for moisture sensitive stone, you need to either use a rapid setting adhesive or a non-aqueous adhesive like an epoxy adhesive that does not contain water. So with a rapid setting tile adhesive, it allows traffic in 2 hours, early strength gain, and it has low shrinkage, high tensile, and extended open time. So with a rapid setting tile adhesive, you will still find that the open time is still, it will be similar to a normal set, but it will set faster than a normal set tile adhesive. Okay, so for epoxy or resin adhesive, They have very good adhesion strength, water resistance, and chemical resistance. It is used for bonding tiles on metal substrates, bonding tiles that is subjected to chemical attacks, or it can use to bond highly moisture sensitive natural stones and bricks. Okay, a case study on repair in swimming pools. We also see slip tiles, debonded tiles in swimming pool, and it can be caused by wrong selection of tile adhesive. There are different types of tile adhesives, and it doesn't, not all one size fit all. So there are some tile adhesive which has better water resistance than the other. So in a swimming pool where it is in submerged condition, you have to use at least a C2 tile adhesive with a S1 classification to accommodate movement in the swimming pool. Yeah, and relative higher water pressure and movement in underwater submerged condition can be also one causes for the bonded tiles in swimming pool. So the material to use, like just now I mentioned, it has to have high bonding strength and flexibility. A C2 and an S1 class tile adhesive will be good. So a Quicksil 604, 602 has been used for tiling in swimming pool in Singapore, in Malaysia, in KL, in Penang. So it has proven as a suitable material for bonding swimming pool tiles and mosaics in swimming pool. And the adhesive for repair, just now we have touched Quicksil 301 in our concrete repair strategy slides. It can be used to put back the debonded tiles underwater without draining off the water, and it has high compressive strength and tensile strength and fast curing with good chemical resistance. So what caused tile grout to deteriorate in swimming pool? So in swimming pool, right, I don't know whether how many people has encountered. Most of the time, if you do grout using a cementitious grout, it's not durable. Over a few years, you will see the grouts start to fall off from the joints. Yeah. So depending on the expectations of the project, we will always like to recommend the epoxy grout because it's much more durable than the cementitious grout. Yeah, although it's more expensive, but it lasts a longer way. So some causes that cause the tile grout to deteriorate in swimming pool: poor water maintenance, poor installation, high movement of water, and wrong selection of tile grout material. So in short, here in summary, here we're talking about when in the swimming pool, right, there's this balanced water that is used in the swimming pool, and because of and depending on the calcium hardness, the pool water will use the free calcium present in cement grout, leading to deterioration and etching because of the difference in pH and alkalinity. Yeah, so normally we will have to investigate the water in the swimming pool as to the pH of the swimming pool if there is this tile grout deterioration issue. So just now we mentioned about epoxy grout. Ardex has a very good epoxy and durable grout called Ardex EG50. It is available in different colors. It has good chemical resistance, excellent water and abrasion resistance, and is water cleanable. So when we use epoxy tile grout, one of the criteria is that it must be able to clean from the surface. If you look at this photo here, when you do a tile grout operation, you actually spread the tile grout over the whole area on the surface of the mosaics or tiles. And after you have filled the grout, the pointings, you have to clean off the tile grout, the remnants of the tile grout that is left on the surface. And it is important that a good epoxy grout is able to clean off using water. Yeah, otherwise, it will affect the aesthetic appearance of the tiles, and that will be disastrous. If this is not removed, it will damage the appearance of your tiles, and you may end up scraping off mechanically, and then again you damage the finishes. So at Ardex Quick Seal, we do have a wide range of tile adhesives to serve different purposes. So here, the Ardex X680, 602, 604, and 615. This section refers to tile adhesive in two components, meaning that it comes with a bag of powder and a bottle of liquids, which you need to mix together on site before tiling. And then we have the Ardex 685, those adhesive that is colored in blue. These are one component. The dark blue, the below 3 tile adhesive, these are one component tile adhesives. So you just need to mix water on site to bond the tiles. And if you look on the left, these are the classification of the tile adhesive. Yeah, the S2 for X680, the first one, will represent a very flexible tile adhesive, and we use this very much to bond tiles on, say, drywall or on flexible substrates. And then we have Ardex WA, which is an epoxy or resin-based tile adhesives, and it has a class of R2T. So, bird's eye view, adhesive base, there are two components and one component. And in the cementitious base for one component, we further categorize it as normal performance and enhanced performance. And we have a normal set and rapid set, and with the product's name. And then we also have a two-component latex fortified that is applied in a bag of powder and a bottle of liquids. Again, we also have the rapid set and normal set. And then the non-aqueous tile adhesive, which is epoxy based, 3 component, which is we have Ardex WA. Quicksil 602, 604, 680, 615, they are all S1 classification, 2 component tile adhesive. Why do you need them? They are for improved water resistance, and this helps to minimize efflorescence and improve cohesiveness of mix, giving better adhesion and durability. Again, here we have a comparison of rapid set and a traditional method system. For screening, if you are using a normal set screening material, at least 7 days of curing, culling 1 day, and grouting 1 day. So altogether, you need about 216 hours, yeah, before you can open to traffic. Whereas for a fast setting system, you have a fast setting screeds here, a fast setting tile adhesive, and an epoxy grout, and this end up with only 38 hours. Yeah, so you see a very great difference of waiting time or drying time between a traditional method versus a fast setting system. But again, a fast setting system will require higher cost. Yeah, so it really depends on the type of application needed on site. Alright, at Ardex, Germany, there's this group of scientists who has developed a new technology called the Ardex Microtech technology to formulate tile adhesives. When the adhesive is mixed and placed, the polymer particles form a film around the cement hydrates and acts as a flexible buffer, yeah, with the components. And Microtech technology contains fibers, and these fibers creates a 3-dimensional binding matrix, offering more avenues to disperse stress and strain. Yeah, so imagine when you are placing a tile over a piece of concrete, and if the concrete is experiencing some stress, this stress will be transferred upwards, and then it will be experienced by the tile adhesive and the tiles. And with microtech technology, right, it is able to disperse the stress and strain. And a reinforced zone to form bonding with the tiles and provides greater strength and flexibility in the tiling system. And that sets us different from the normal grades of tile adhesive in the market. And in addition with the microfibers, it also enhances the performance relating to longer open time, bond strength, and ease of use. So if you look at this photo here, the top is a test that was done using premium thin set motors, meaning a bag of C2TE tile adhesive, and then the bottom tiles, it was done using Ardex Microtech tile adhesives. And you can see that you will not be able, the coverage at 0 minutes, meaning after spreading the tile adhesive, the tile is placed directly and immediately over the tile adhesive. And after placing, right, we actually remove the tiles to check the coverage. We see it's almost similar. We have at least 90% coverage. But as you leave the tile adhesive to dry in the air dry for a longer time, 10 minutes, 20 minutes, 30 minutes. If you look at the 30 minutes, you see that the premium thin set motors has very little coverage, meaning that the tile adhesive has already started to skin. Yeah, but with a microtech tile adhesive, you are still able to achieve maybe 85% coverage. So with the difference in open time, right, and the difference coverage, it actually helps in the bonding. It actually helps to enhance the bonding of the tiles to the substrate using microtech. And then we have another series which is the rapid setting tile adhesives, and this uses auto rapid technology. It uses special binder to deliver high early strength within the first 6 hours, and during the curing stage, water is completely consumed, resulting in no water surplus, and the shrinkage-free high-strength system is achieved, and virtually it eliminates the risk of water staining. Yeah, so again, this sets us different from the market fast set tile adhesives, and this is the Ardex X685 utilizes the rapid dry formula technology or the auto rapid technology in the engineering. So as mentioned here, 100% of the water added to the product is chemically converted into a hydrated silicate matrix, and this helps to, first of all, helps to cure and dry the adhesive and reduce staining on stones. So with a fast setting system, right, A35, X685 and EG, you require only less than 51 hours to complete the tiling work. So if you look at this video, right, the left should, oops, sorry. The left side of the video shows normal OPC type of adhesive, and this is the adhesive using rapid, auto rapid technology. So when you look at the difference, you can see the difference. The one on the right shows that the tiles is still adhering well to the street or the concrete. Yeah, because the Adu Rapid technology is able to accommodate the stress that is from the streets or the concrete traveling upwards to the tile adhesive and the tiles. Whereas if you look on the left, the adhesive that is based on normal cement will not be able to accommodate the movement or the stress from the concrete, and this can lead to the bonding of the tiles, detachment of the tiles from the substrate. So we do have cementitious and resin-based tile grout. F4 is a cementitious unsanded tile color grout up to 4 and is suitable to fill up to 4 mm joint width. FG8 is sanded, meaning that it has fine sand in there, and it is suitable to fill gaps from 1 mm to 8 mm joint width. And then we have the resin-based epoxy tile grout, which is a 3-component, and this is suitable to fill joint width of 1.5 to 15 mm. And we have an Artex grout booster, yeah, something like Guditui, that you can mix into F4 and FG8 to provide better water resistance. This is our color grout for cementitious. Altogether, there are 18 colors that you can select. And then for epoxy grout, there are 8 colors. And then we also provide protection to floor tiles immediately after completion or after defects has been rectified and surface cleaned. Quicksil 705 is a polyethylene reinforced with fiber for protection of newly laid finishes, and is lightweight, easy transportation and recyclable, meaning that after you have finished the work at one site, the workers can actually go back and then bring over to the next site to use. So you actually have one roll and you can recycle to many sites for usage. And quality control, you can do a random test on the tiles using a steel ball rod to observe for hollow sounding. So if hollow sounding is observed, then you can map out the hollow areas, determine the cause, inspect the installation method, assess the impact before deciding on the repair methods. Yeah, retile if hollow sounding is less than 20%. Oh, sorry. Retile if hollow sounding is more than 20% in dry areas and more than 5% in submerged external areas. So in summary, adopt the right practices of tile installation to ensure durability. Select the right tile adhesive to suit with the tile substrate and service condition. And movement joints should be provided to limit movements, and tile and grout should be properly protected for proper setting and hardening. Okay, we have come to the end of the tiling presentation. Any questions?
Okay, thank you very much, Celia. Let's give Celia a round of applause. The final event of the day would be the presentation of certificates to today's speakers and to the organizer of today. First and foremost, I would like to invite IR and Lillian to give out the certs. I would also like to invite Colin from Cogri to receive the certificates. Okay, thank you, Cogri.
Okay, thanks. Thank you very much. Sure.
Next, we would like to invite Celia on behalf of Lkl to receive the certificate. Last but not least, Kenny on behalf of Lkl to receive the certificate.
Your hands up. Thank you. Thank you. Thank you.
Okay guys, with that, that's the end of today. Thank you very much for coming. If there's any further questions that you want to ask personally to any one of the team from Cogri, from Lkl or from Lkl, feel free to reach out for us after this. Otherwise, remember to scan the QR code, pay for the parking. It's valid until 7 o'clock, so as long as you get out before 7, 10 ringgit flat rate. Thank you very guys for coming. See you all next time. If there's any problem scanning, paying with the QR code, kindly reach out to the reception downstairs. They can help you out with the payment. Thank you.